and blue. So if you're just using a single processor chip and you're not doing threading, then even this simple exercise can be quite difficult, that you're playing notes at specific points in time and you're blinking the LED. But for kids, this is exactly what they want to do. They just want some music playing and they want some lights going on. And then, of course, they want it to move. And so movement we can do also with a start block, or we can do event programming by using the when block. And then the T-bot has some buttons, so here's the left button pressed. And then I can use the motion button. So I can load this. So this will still link our light. It'll play the music. And when I press this button here, it moves a little bit.
So is it possible to put together programs that can't be run? And if you do something like that, how is an error indicated?
Is it possible to break this? Always. You can always break everything. So some things can't easily be broken. So I think it's very difficult to break the color chooser. So maybe if you type a really large number in there, you can break it. Same thing with the plug store. So these are sort of the things that I would start out with. Using simple apps where it's possible to break things. If I type in an undeclared variable in here, then yeah, so here we go. Okay, so I think that's actually, why did you do that? Okay, so this is what it actually does. It shows you there's a bug in the highlighted block, and it highlights the block, and then it says unknown symbol BE, and it references you to the generated text as well. So that's how it should behave. I'm running this here, so I had some assertions that I take the easy way out. So we've done. So yes, you can do bad things, and in that case, it will highlight the block. And it will give you some error message that's specific for that block. Inter-process communication. So with 12 blocks, everything is always global memory. So you have one global memory, and you can have local variables to a function. So a function looks like this, where you can give it a name, the Verity function, and this is the argument to it. So the h-bridge is the argument that you pass into it, and then bool is the local variable. You can have multiple of these. And then this creates a caller block that looks like this. And so in this case, I pass a value of 1 into the function, and then an h-bridge uses that. But normally, everything is a global variable, and global across all the processors. And the propeller guarantees that writing to those variables is atomic. So you write the variable and it gets that value. Obviously, if you have multiple processors writing different values to the same variable, then you have issues. And so then you talk about loss. Okay, so let's maybe use Yeah, let's go from here to some sensors. A good sensor to do with kids is sound. And so under the sound menu is the lead microphone block. This is a funny block which doesn't really fit into here. It's a different shape and it's a different behavior. But I can use a variable block, so a set x2, and then I get the same shape that I have here, so I can take this and just dock it inside of there. And I can also take some interface blocks. So the simple one is a variable values. Just try this. So now as I'm talking, that valuable changes. So that could be useful for some things. But much more useful is to graph these variables. And so here is a block, and these types of blocks I can change. And again, everything that's in yellow you can click on and change. So I can click on this area, and now I can say, I can change the title here. So that's my title in there now. I can change the time scale that I'm using to display my voice. So here's my voice in real time streaming across there. The dad doesn't like the auto scaling, so you can turn it off. And then give it minus 500 to 500. And now when I'm talking, so that's some of 12 blocks and so that's taking a variable and setting it to a sensor reading. You could, of course, also use conditions or when blocks to do behavior based on that. And the next demo that I'll attempt here is to use fiducials. So there's a fiducial mark on here. And I'll attempt to steer the robot with the camera and 12 blocks. So give me a couple of seconds to set this up. I'll try to talk you through it. So I'm going to take the T-bot and uncouple it and set it here on the table. So now it's running some software written in 12 blocks that uses the Zigbee chip. And now I'm going to connect my USB cable to a base station that talks to Zigbee to the processor. And finally, I'm going to make sure everything's turned on and load the file. Find it. So the goal was so the goal of this is in the next couple of days try to do Pong, where you're taking a ball and moving back and forth, all done with fiducials, so that you don't have to invest in expensive lighting and cameras, but you can just use software and a normal webcam and a PC to get kids doing soccer with robots. So let's see. This is a side project of mine. $10 hammer soap, and it's been hopefully, yeah, so the fiducial marker here doesn't have any green on it, but when I take this camera and run it through the software, it now puts a little 0 in the marker on there. So it's telling me that it's discovered this particular marker, and it can tell me the position and orientation of that marker. And 12 blocks, and use that and show me that. So here it's updating, and so when I rotate this, that number is updated. So now comes the big important moment. Seems to work. Sacrifice the right type of things. So here's a robot. If you can't see the robot, you can look at the screen there. And I have a simple little program that just looks at the angle that I'm given from the fiducial marker. You'll see that it's somewhat intermittent because I'm shaking and lighting is on, but it's trying to keep that angle to 180 degrees. So if I rotate my hand, pretty quickly the robot orientates itself with that. So that's one function. That's what this block over here does. It moves the remote robot a set speed for a set amount of time, and that time is proportional to how much difference in angle there is. And so when I'm rotating quickly, it'll rotate quickly. Okay. So it's just a different way of controlling a robot. And this other part up here says that if the angle is pretty close, so if it's between 170 and 190, then I'm going to use the X position to control the speed of the robot. So if I move it out of, if I move the robot to the left side of a picture, then I can make the robot move forward. Or I can move it the other way around. So I can steer it just by sort of moving my hand back and forth. Yeah. So summarizing, education is good, and STEM is very important. With 12 blocks, I showed very simple ways of programming the keyboard. So starting with the lights, going on with the sounds and movement, and then going up to quite complex, where you're doing wireless communication, and you're doing fiducials, you're doing computer vision, and all of that in the same type of environment. I call it 12 blocks because I think in 12 blocks, I don't know how long this program is, but I think it's over around 12 blocks. I think you can do almost anything. Any questions? Someone's going to have to repeat that roll.
So do you produce the STEM code, modify the STEM code?
Oh. You want to see more demos? Okay. So the code generated by 12 blocks is actually spin when it's targeting the propeller. And so here is a simple program. Let's get a LED again. I'll add a lead in there too. And here's my program. That's what it looks like visually. I can now click on View Code. And this is the text representation of that same program. when generated for the parallax propeller, which is running spin. So if you program the propeller, here's the clock mode and the frequency. And as we go down, we can see the actual code that's in here. So here's the set RGB, and the 0 happens to be black, and then the pause. So when kids get started with this, they may only look at the visual part, but then just like we did when we looked at browsers 10 years ago, we clicked on view source, and that's how a lot of us learned how to create websites. And with 12 blocks, there's that same philosophy that the code is always available to you. So even when you save a 12-box file, it's just saved in the spin language when you're targeting the propeller. I go one step further, so I show you the code in this editor, but you can make changes in here. So I can take this and copy it, and here I'll paste it, so now I have two of these, and I'll make one of these a different number and change these to 100 and 100. And now when I save it, this side is now out of sync with this side. But I can go back to 12 blocks, and I didn't have a breakpoint there. And it says, do you want to reload it? So it's recognized that the underlying code has changed, and so I can say, yes, I want to reload it. And then it's brought up these changes, that there's a weight in there, and it's also picking up the color. So it's, people call this full circuit, like you're going from the visual representation to text, and then back to the visual.
So does it handle if you make an error in the code editor, does it recognize it when you're doing that?
So again, this isn't perfect. So, and you actually saw a little bug. So I didn't get the indentation quite right, and then so I think this is actually meant to be over here. And so that's what I expected to see. So if you put some code in here which it doesn't recognize, then it's going to comment it and tell you that the library doesn't fully support it, and then that the thing that it didn't recognize has been commented out. In the back. So the simple apps I was referring to are things like the sound one, right, where you have this type of thing going on, and then you click on it, and you have this type of editing, as well as the color one, where you just click on the color and do different colors like this. I'll use that to segue into another mini demo, which is that 12 blocks is very customizable. So I'm working with a number of companies on taking 12 blocks to support their specific hardware. And just as an illustration of that, so here's the current set of blocks. Here's the weight block as an example. And I can go into Notepad, my editor, and this XML file fully describes the language of 12 blocks and how it outputs to a variety of different languages. And so I can go into this while 12 blocks is running and make a change. So here's the weight block, and it's a node, and it has a certain class, and it has a parameter which is given in time in milliseconds duration to the default value. And I'm just going to change weight HBRC, I type that in there. And now when I save this, and then go back into 12 blocks, the block coming from the library now is the weight HBRC, so I've changed the 12 blocks language on the fly. And I can change parameters and everything in the language. It's all specified in that XML file. And if I want to target additional platforms, it's a matter of changing that XML file. And I've supported different languages from C to BASIC to Spin with that already. There's another question over there. Is there documentation? So I have written a couple books, and I prefer to be adding features and doing stuff like that. But yes, there is some documentation. Probably not enough, but there'll always be more documentation. So yes, on the website you'll find several development kits and other items. But you can always ask me or ask some of the people that run the forums. When cross-platform? 6 months ago. Mac and Linux are supported as well. I'm more a Windows guy, so the very latest, greatest, and with integration to ROS and OpenTV and so on is more on Windows and less on other platforms. But I think that's it. Thank you for having me here, and I'll be back next week.
So that concludes our talk for the evening. And so I'd like to thank everybody for coming and go into what we call random access just to talk to one another. And around 10 o'clock we get kicked out. Some of us keep on talking. So thank you very much, and we hope you enjoyed it. And hopefully we can see you next time. Thank you very much.